Okay, right now we have one problem on slide 17, so let's work on that. The average pH of normal arterial blood is 7.4. So we're given a pH of 7.4. At normal body temperature, which is 37 degrees Celsius, Kw is equal to 2.4 times 10 to the minus 14. Calculate the H plus concentration, and I'm going to keep writing it so you get used to it, or H3O plus is the same. The OH minus concentration, we write it this way just because it's easier than writing all of this. And the pOH for the blood at this temperature. Okay, notice because we are not at room temperature anymore, it gives you a specific value for Kw at this temperature at 37 degrees Celsius. And unless it's specified like it is here, just assume Kw is 1 times 10 to the minus 14th. But because it tells us we're not at 25 degrees Celsius, it tells us what it is. And we're going to use this value for Kw, not 1 times 10 to the minus 14. Okay, I don't have anything other than these two values, first of all. I have a pH. I don't have an H plus concentration, but I have a pH. And that, because I have that, I can calculate the concentration of or the H plus or H3O plus. The other formula, remember a slide or two ago, I said that you're going to remember two formulas that you are going to use for this chapter. One was the pH. I said pH is equal to minus log of the concentration of H3O plus. The other one is concentration of H3O plus is equal to 10 to the minus pH value. How do you use these two formulas? Remember these, memorize these. You're going to use them a lot in this chapter. You use the top formula if you're given the concentration of H3O plus and you're asked to find the pH. In this case, we're not dealing with that because we don't know the concentration of H3O plus, but we do know the pH. For that, you use this second formula. To find the concentration of H3O plus, if you know the pH, you use this. H3O plus is equal to 10 raised to the power of minus your pH value. So let's calculate that. H3O plus is equal to 10 raised to the minus 7.4 value for the pH. If you do this calculation correctly in your calculators, you should get a concentration of 3.98 times 10 to the minus 8th molar. So now I figured out the concentration of H3O plus by just using the pH. When you know the pH value, you use this formula. To find the concentration of your acid, you take 10 to the minus the value for the pH, which in this case was 7.4. Now that I know H3O plus concentration, I know Kw, I can figure out the OH minus because I know their relationship between them. No matter what the value for Kw is, no matter what the temperature, this relationship is always true. OH, concentration of OH minus times the concentration of H3O plus gives you the value for Kw. To isolate OH minus, you divide by H3O plus concentration both sides. Whoops, wrong one. H3O plus H3O plus cancels out, and my OH minus is equal to 2.4 times 10 to the minus 14 divided by 3.98 times 10 to the minus 8th molar. This comes out to be 6.03 times 10 to the minus 7th molar. That is my concentration of OH minus. Now I'm also asked to calculate the POH value. Notice this is very similar to this formula, but I have OH and POH, and I have OH concentration here. Now I know the concentration of OH, so I can figure out the POH, which is minus log of the concentration of OH minus ions is equal to minus log of 6.03 times 10 to the minus 7th. And this will give you a POH value of 6.2. Okay. I can't directly speak about the value of POH because it's the opposite of the pH scale, but if I were to think about if the blood is basic, acidic, or neutral, I could take 14 minus 6.2, and that would be 7.8, a pH of 7.8, which tells me that the blood is a little bit basic. Okay, it's a little bit on the basic side because it's a little above the neutral pH, which is 7. Okay, I will once again erase this and we'll move on to the problems in the next slide.